Alright, today we will be solving this system of equations that was sent to us by Michaela. Thank you, Michaela. This looks pretty tricky. These are two circles, so we are looking for the intersection. You know, if we have a circle and another circle. Whoa. Okay, those are horrible circles, but you get the idea. We're looking for those points of intersection. Now, with all the decimals and such, it may be tedious, but I think we can get it done. Alright, both of these equations need to be written in general form without the parentheses, but we'll start with this yellow one. So a couple of things. First of all, the decimals. I think we would prefer to have these as fractions. So 2.5 is the same thing as 5 over 2. So let's use that instead. So this is x plus 5 over 2 squared plus. Now we have y minus 0, but the minus 0 part isn't doing anything, so that's just y squared. And 1 squared is just 1. So we're simplifying. Now let's take this part and simplify it out. So x plus 5 over 2 squared is x plus 5 over 2 times x plus 5 over 2. Alright, so we're going to double distribute this. So if we do that, so I'm multiplying x by everything, so that's going to give me x squared plus 5 over 2x. Now if I multiply the let's see, if I multiply the 5 over 2 by everything, I'm going to get another 5 over 2x plus 5 over 2 times 5 over 2 is 25 over 4. So I'm going to get that. Combining these like terms here is going to give me the following. So I'm going to have x squared plus 5 over 2 plus 5 over 2 is 10 over 2, which I'm going to reduce in a second. So this is 10 over 2x plus 25 over 4. But of course 10 over 2 is just 5. So let's just go ahead and put 5. Alright, so this is what we get when we multiply these two together. So it's time to bring down the rest of the equation. Alright, so I still have the plus y squared and equals 1. Now, I'm going to leave this equation in this form for now. I'm going to leave that alone and move on to the pink equation. A lot of times I'll try to get 0 over here because our ultimate goal is to set these equations equal to each other. But I see we have a 1 over here anyway. So if this has a 1 and this has a 1, they're both equal to 1. So we will be able to set them equal to each other without 0. So let's do a similar thing on the pink one. 1.25, let's change that to a fraction for sure. 1.25, alright, that's 5/4. So this equation is the same thing as x plus 5 over 4 squared, and then y plus 5 over 4 squared, and that's equal to 1. Alright, so this will be a little bit tedious because we have to do these out. But what are you going to do? So we will have to do x plus 5 over 4 times x plus 5 over 4. Right? And we will have to do y plus 5 over 4 times y plus 5 over 4. Only thing is, once we do this for the x's, we can just sort of copy it for the y's, since it's basically the same thing with a different variable. So if I distribute the x, that's going to give me x squared plus 5 over 4x. And then if I distribute the 5 over 4, that's going to give me 5 over 4x plus 25 over 16. If I combine these like terms, then I'm going to get x squared plus 5 fourths plus 5 fourths is 10 fourths. So that would be 10 fourths x plus 25 over 16. But 10 over 4 simplifies down to 5 over 2. So I'm going to reduce that. By the way, I'm getting over sickness. I don't know if it's a cold or some other virus, but you might be able to hear my voice is not 100%, so that's what's going on. So I'm going to copy this for the y's because I know it would be the same thing. So this would be plus y squared plus 5 over 2y plus 25 over 16 is equal to 1. So let's clean this up just a little bit by combining the 25 over 16 plus 25 over 16. Well, 25 plus 25 is 50. So if I put these together, it's going to be 50 over 16. Okay, but that reduces, doesn't it? So that's going to be the same thing as 25 over 8. So I think I'll just erase that as well. Okay, so can we agree that if I combine these two together, I'm going to get 25 over 8? So will it be too confusing if instead of recopying the whole thing, can I just erase this and make this the 25 over 8 that we spoke of? Okay, so I'm just cleaning it up a little bit. So this is the end of the road for the pink equation. So now I need to take the yellow equation and set it equal to the pink equation. Since they both equal 1, they should equal each other. So that's what I'm going to do. Alright, so here I've set the yellow equation equal to the pink equation. Now let's subtract to get everything onto one side. A lot of things are going to cancel out. So for example, if I subtract x squared from both sides, then those cancel out, no more x squared. If I subtract y squared from both sides, no more y squared either. So let's take a look and see what we have so far. Let's recopy this. So now I have 5x plus 25 over 4. Okay, so that's gone. And this is equal to 5 over 2x plus 5 over 2y plus 25 over 8. Alright, my next goal is to get one variable by itself. Usually I'll get the y by itself. Basically I'll try to rewrite this in the form y equals mx plus b, so I can do a substitution. I'm really fed up with all these fractions though, so what I'm going to do is multiply by a number that will cancel out all of these pesky denominators. I see I've got 4, 2, another 2, and an 8. Well, guess what? All of these things are factors of 8. So I am going to multiply the both sides of the equation by 8. which in effect means I'm going to multiply by 8 every term. Alright, and multiply every term by 8. When all the dust clears, I will have no more denominators. So 8 times 5 is 40, so I have 40x. Okay, right here, 4 goes into 8 twice. So that's going to leave 2 times 25, which is 50. 2 goes into 8 4 times. That leaves 4 times 5, which is 20. Alright, 2 goes into 8 4 times. 4 times 5 is 20. And of course, these 8s just cancel out. Okay, so that's much better. No more denominators. So I'm going to go ahead and see if I can get y by itself. So I'm going to start by subtracting 20x from both sides. And you know what? While I'm at it, I might as well subtract the 25 as well. So that's going to leave me with 20x plus 25 is equal to 20y. Alright, so I'm close to having y by itself. I will just divide everything by 20. Okay, so if I do that, then these cancel out. So I just have x. Now this will reduce. Alright, both of these are divisible by 5. So this will be 5/4. And this will equal y. Okay, so y equals x plus 5/4. That means the next time I see a y, if I want to, I can replace it with x plus 5/4. So that's what I'm going to do. So I'm going to do a substitution using this fact. And I'm going to do it in one of my two original equations, either the pink or the yellow. I say original, but what I mean is I'm going to use one of these forms without parentheses, general form. And let's see, so I'm just trying to decide which one looks simpler to me, the pink one or the yellow one. You know what, I'm liking the yellow one. So what was that again? We just decided that y equaled, I think it was x plus, and I think it was 5/4. I have a horrible memory. So I'm going to look back down. X plus 5/4. Okay, so y equals this guy. So I'm going to do that substitution. So this should be easy because in this equation it only has the one y right there. Okay, so if I do that substitution, let's see what happens. Little craziness there. Alright, so here I've substituted in the x plus 5/4 in for y, and so that's what's happening. Now, of course, I need to go ahead and square this, and so that's going to be like this. So I'm going to have x plus 5/4 times x plus 5/4. Alright, so if I do that, if I distribute the x, that's going to give me x squared plus 5/4x. And then if I distribute the 5/4, then I'm going to get another 5/4x plus 25/16. Now if I combine my like terms, then I'm going to get x squared. 5 over 4 plus 5 over 4 is 10 over 4 x plus 25 over 16. But of course 10 over 4 is 5 over 2. Okay, so this is what you get when you multiply out x plus 5 over 4 squared. So I'm going to bring down the rest of the yellow equation. So all of this is equal to 1, of course, and then I had my 25 over 4. Okay, and I have my 5x, and I have my x squared. Alright, notice how this equation has nothing but x's in it. So, I should be able to solve this. Alright, again, I'm not liking the fraction, so I'm going to multiply by 16 because all of these numbers are factors of 16. So I'm going to multiply every single term by 16 to get rid of the denominators. Okay, so that is going to give me so I will have 16x squared. Okay, 16 times 5 is 80. So I've got 80x. 4 goes into 16 4 times, and 4 times 25 is 100. So this will be 100. And then I've got 16x squared. 2 goes into 16 8 times. 8 times 5 is 40. These 16s cancel out. And here I will just have 16. Alright, I prefer to work with no fractions when I can. So let's combine like terms next. So 16x squared and 16x squared make 32x squared. So I have 32x squared. And then 80x plus 40, that's 120x. Alright, and then I've got 100 plus 25, that is 125. And that's all equal to 16. So let's subtract 16 from both sides. So then I'll have 32x squared plus 120x plus 109 is equal to 0. So I'm looking at this and I'm thinking quadratic formula. If these numbers were smaller, I might try to factor it. But they're very large. So let's do the quadratic formula. So you know how the quadratic formula works. It's all about this. Should I switch colors? I feel like I want to switch colors. I'll do green. You know how the quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, well b is 120. So opposite of b, that means we'll have minus 120 right there. And then b squared. You know what? Alright, well here it is with everything all plugged in. I like to do the part under the radical next. It's called the discriminant. So the 120 minus 4 Alright. So 120 squared minus 4 times 32 times 109. Alright, so it's 448. Let's see what the square root of 448 is. Eight radical 7. Alright, I was really hoping we were going to get a perfect square, but we were not that lucky. Now, all three of these numbers are divisible by 8. So let's reduce by doing that. Whoops. So that's going to give us 120 divided by 8 is 15. So I'll have negative 15 plus or minus radical 7 over 8. Alright, so these are the answers. We're going to have to convert them into decimal approximations. Unless I already made a mistake somewhere along the line, these are not rational. So there's no exact decimal that we can have. So we're going to have to approximate somewhat. So I'm going to go ahead and make a table of values right now. So I've got x, I've got y. Okay, so if I put this in my calculator, negative 15 plus radical 7 over 8. That gives me negative 1.54. Okay, that's an approximation. Now, if I do the same thing with a minus, then I get negative 2.21. Alright, so these are my two x values. Now I just need to find the y values that go with them. But remember, we have that little equation. Actually, let me see if I can remember it. Remember, we had found the equation that y is equal to x plus, and I believe it was 5 over 4. Yes. Okay, so let's use that little equation to find the y's. So if we do negative 1.54 plus 5 over 4. So that's negative 0.29. And if we do negative 2.21 plus 5 over 4. That's negative 0.96. So, unless I've made a mistake somewhere along the way, these should be the coordinates of the intersection of our two circles. Okay, so we're talking about the points which are negative 1.54 comma negative 0.29 and negative 2.21 comma negative 0.96. Now, I'm worried, that was so many steps, I'm worried I made a mistake somewhere along the way. So the moment of truth is we're going to go to Wolfram Alpha and check and see how I did. Okay, so here I am at wolframalpha.com, and here's how I would type in the system. Now let's see what it says. Okay, so it's showing us our intersections here of our two circles. I'm seeing it's looking promising because I'm seeing the solutions are irrational. Alright, I'm seeing that square root of 7 happening. Did they give us a decimal approximation somewhere? I clicked on where it said decimal approximations and I got this. So what I'm seeing is negative 2.2 and negative 0.96. Oh shucks. Check it out. And then do we have the other one as well? The negative 1.54 and the negative 0.29. Nailed it. Okay, so as crazy as it was, that is the solution to this equation. So as you can see, I spent like 25 minutes on this problem. So I mean, I probably could have done it faster if I wasn't explaining every step. But still, this was a complicated problem. There's just no easy way to do the problem. But I hope it was helpful, and hit me up with a comment if you need anything. Let me just mention one more thing. Back at the beginning, when I converted from decimals into fractions, in retrospect, I probably did not do myself any favors. I think I made it harder by creating all these fractions, and then I would multiply through by something to get rid of the fractions. I think if I had just stuck with the decimals, even though it was ugly, I think it would have been easier if I had just stuck with the decimals.